Good afternoon. This is a presentation, a conversation of sciences, design proposals for climate change adaptation as input and vision for innovative policy implementation, presented in the conference Education, Design and Practice, Understanding Skills in a Complex World, being held in 2019. The Gulf of Guayaquil is located in Guayaquil, the biggest city of Ecuador, and known as one of the cities worldwide that will experience the highest average annual losses due to climate change. This is written in Hallegate et al. 2013. The case that is going to be explained here has the particularity of exploring the relation between a rural area of the city, which is the Gulf, and the socio-ecological conflicts that characterized the area. The Gulf of Guayaquil is a fragile estuarine ecosystem that is the home of local species such as red crabs, oysters, and cockles that are the main source for the livelihood of the ancestral communities that live in the area. Due to the characteristics of the area, private investors have used the area to install shrimp farms. This is a prosperous business, since shrimp is the first product of export of Ecuador. On the contrary, communities that share the space live under extreme poverty. The Gulf is also the home of mangroves that provide coastal protection to communities and shrimp farms, being an effective resource for climate change mitigation and adaptation. There are factors that have interacted to make the Gulf of Guayaquil vulnerable to climate change effects, being the main one the concession of land for monoproductive shrimp farming given from the government to private businesses. Facts associated to the increasing number of shrimp farms in the Gulf since 1969 are the felling of mangrove and the changes in the landscape of the zone. Information reported by the Center of Integrated Surveys of Natural Resources by remote sensors indicates that while hectares of mangrove decreased between 1984 and 1999, hectares of shrimp farms increased over the same period of time. Now we're going to see the impact of regulations in the Gulf ecosystem in 3 points of time: 1969, 1984, and 2018. Visual evidence for this research was produced based on different sources to show the impact of shrimp farming over time and related to the legal framework that allowed these changes in the landscape and the ecosystem. The analysis starts with the second picture, which was bought by the Faculty of Architecture at KU Leuven, Belgium, from the Spatial Institute of Ecuador, and shows the land use between shrimp farms and mangrove in 1984 in a specific area of the Gulf. Then, with the use of Google Maps, it was possible to capture the distribution in 2018 of mangrove and shrimp farms in the same study area. Finally, the picture of 1969 was created in Photoshop using the patterns of the natural ecosystem and considering that in 1969 there was no concession for aquaculture activities and that the Ecuadorian ecosystem of the Gulf was only inhabited by the communities. I applied calculations summing up the total amount of hectares of mangrove and shrimp farms, not considering the hectares of salt flats, and then obtained the percentages that show the weight of each concession, mangrove and aquaculture, as part of the total. The results were striking, indicating that in 1969 the Gulf had 100% mangrove area available and 0 hectares of shrimp farms. But over time, it got to have less than half of the mangrove area it used to have, and almost 150,000 hectares were converted to private aquaculture activities. In 2018, there are 2.28 hectares devoted to shrimp production for every hectare of mangrove, and this deforestation has 2 main effects. The first one, increased coastal exposure to sea level rise, and second, endanger the livelihood of the communities. The understanding of these situations was a product of a multidisciplinary approach that combined landscape architecture studio work, social sciences, and public policy. After the ethnographic work, visual, legal, and statistic data analysis, design projects were developed. The one selected to be presented here is called Reverse Colonization by Fariha Sheikh, which was developed in a landscape architecture class. It proposes a 2030 innovative vision, calling for the conversion of 50% of shrimp farms for different ends, such as topographic manipulation, reforestation, water treatment, integrated and diversified aquaculture, and the use of chinampas, which are artificially created islands used for growing crops, a Mexican agriculture technique. Reverse colonization proposes to find a balance between aquaculture activities and natural ecosystem through the construction of dikes on phase 1, followed by a sedimentation process conversion to separate pond systems, meaning the coexistence of mangrove and aquaculture activities. This will lead in 2030 to have naturally restored mangrove, taking 5 to 10 years to grow. The proposal includes the use of the area for ecotourism, research, pedestrian and public routes, and in general, a new livelihood for the shrimp farmers and the communities. All this under an eco-friendly and environmental sustainability vision. From the public policy approach, it was analyzed that in order to reach this vision, it's necessary to amend national regulations, so the proposal is to change the typology of the concessions and start renewing them with a condition for businesses to devote a percentage of the land for diversified uses until the vision is achieved. In this map, it can be shown that geographic information systems are useful instruments because they can help to execute a more efficient fulfillment of Decree 1391, the legal instrument that rules for reforestation in Ecuador. The first thing is to identify the areas where reforestation is critically needed to protect communities or infrastructure against sea level rise. As known, sea level rise and increased temperature of air and water are manifestations of climate change. Reforestation will require to move back shrimp farms' infrastructure to leave the borders free to plant mangrove, so it is necessary to start with the areas that are less protected because they have a thinner layer of mangrove. We can join these ideas to the design of fiscal mechanisms, for example, tax reductions linked to incentives for reforestation for shrimp farmers will form an integral public policy towards conservation and adaptation. To conclude, I invite you all to think of the future implications of the socio-ecological conflicts that have been discussed during this presentation and to reflect about climate change. In 2018, Ecuador produced geographic information about the location of irregular shrimp farms in the coastal zone. This would be a tool for the government to start first reverse colonization interventions with diverse aquaculture, reforestation, research and ecotourism initiatives with the communities in these illegal shrimp farms. It is important to say that this shift of paradigm will require political will to change the status quo. Therefore, it is clear that, as well as design, social sciences, and public policy are needed, politics are also a crucial component to implement actual changes for adaptation and mitigation to climate change.